The James Webb Space Telescope represents a monumental leap in our quest to understand the universe. It's not merely an upgrade to older telescopes, it's a completely new kind of observatory. Its primary mission is to peer back in time further than ever before. We want to see the very first stars and galaxies forming after the Big Bang. Webb is designed to capture the faint ancient light that has traveled for over 13 billion years to reach us. This is kind of like looking at a cosmic photo album from the universe's infancy. To achieve this incredible feat, the telescope needs to be exceptionally sensitive, capable of detecting the faintest whispers of light from the dawn of time. This sensitivity presents an enormous engineering challenge. Webb observes the universe in infrared light, which is, in essence, heat radiation. Any source of heat can interfere with the telescope's observations. Even the telescope's own heat could blind its delicate instruments, much like how the sun's glare can make it impossible to see stars during the day. Webb needs to operate at a temperature below -223 degrees Celsius. That's colder than any natural temperature found on the surface of the Earth. The primary source of heat that Webb must contend with comes from our own star, the Sun. The Sun's light and heat are relentless. The solution to this problem had to be both ingenious and robust, a shield unlike any other. The answer was to build a giant, multi-layered sunshield. This sunshield acts as a colossal parasol, constantly positioned between the telescope's sensitive optics and the Sun, Earth, and Moon. Its job is to block the incoming heat and light, allowing the telescope to cool down to its required cryogenic temperatures. The scale of this protective shield is truly immense. When fully deployed, it spans an area roughly the size of a tennis court. It's made of 5 distinct layers, each one thinner than a human hair. These layers are made from a special material called capton, which is coated with aluminium and doped silicon. This combination gives the sunshield its shiny silver appearance and its incredible ability to reflect sunlight. The 5-layer design is a clever way to shed heat. Each layer is cooler than the one below it, creating a temperature gradient. This sophisticated design means the sunshield provides a staggering amount of protection. It reduces the energy from the sun by a factor of more than 1,000,000. On the sun-facing side, temperatures can reach over 85 degrees Celsius, hot enough to boil water. However, on the cold, shaded side where the telescope's mirrors and instruments reside, the temperature plummets to the frigid lows required for science. This incredible difference in temperature, separated by just a few meters of thin material and vacuum, is a stunning feat of thermal engineering. It creates a stable, cold environment essential for the telescope to function. Folding the sunshield was not a simple matter of just bunching it up. It was a highly choreographed procedure, more akin to celestial origami than simple packing. This colossal structure had to be packed down into a space small enough to fit inside the payload fairing of an Ariane 5 rocket. The chosen method was a fan folding or zigzag pattern. This allowed the massive sheets to be compressed into a long, narrow shape. Alongside the membranes, the support structure also had to be collapsible. This led to the development of telescoping booms and hinged components. Before Webb could be trusted to unfold itself millions of kilometers from home, it had to prove it could do so on Earth. This led to one of the most grueling testing campaigns in space exploration history. Engineers had to devise a sophisticated system of cranes, pulleys, and counterweights to offload the gravity, allowing the shield to deploy as if it were floating in space. These ground tests were not just a simple check to see if things worked. They were designed to push the system to its limits, to find weaknesses and flaws. During a crucial deployment test in 2018, the engineering team faced their worst nightmare. Several tears had appeared in the delicate capton layers. The investigation quickly pinpointed the cause. During the complex folding process, cables had become snagged, causing immense force on the membrane. The solution required a multi-pronged approach. They had to redesign parts of the system to prevent the snagging from ever happening again. First, the engineers had to repair the tears in the priceless flight membranes, a delicate procedure that involved patching the ultra-thin material. By finding and fixing the problem on the ground, they ensured that the real performance, millions of kilometers from Earth, would be flawless. After a flawless launch on Christmas Day 2021, the James Webb Space Telescope began its month-long journey to L2. But the journey itself was far from passive. It was during this coasting phase that the most complex and riskiest part of the entire mission had to take place. This was not a single event, but a meticulously planned sequence of over 300 individual steps, each one a potential single-point failure. The centerpiece of this sequence, and the most nerve-wracking part for everyone involved, was the unfurling and tensioning of the giant Sunshield. The most dramatic phase began on the 6th day after launch. The first major move was the extension of the two mid-booms. On Earth, the mission control team watched the telemetry intently. They could see the motor currents, the boom extension measurements, and the strain on the membranes. It was a slow, majestic, and incredibly tense process. The tennis court was beginning to take shape. The next critical step was to release the membrane covers, exposing the 5 layers of the Sunshield for the first time in space. With the Sunshield fully unfurled, the final nail-biting act could begin: layer tensioning. This was the process of pulling each of the 5 gossamer-thin layers taut. The team monitored the motor currents and cable tension with extreme care. Any unexpected spike in friction could indicate a potential snag. The process was repeated over the next 2 days for each successive layer, each one bringing the mission closer to success. On January 4, 2022, 13 days after launch, Mission Control received the confirmation they had been waiting for. Layer 5 was fully tensioned. The Sunshield deployment was complete. The single most complex and risky deployment in the history of space robotics was a success. With its 5 shimmering layers fully tensioned and locked into place, the Sunshield began its silent, lifelong vigil. Its primary purpose, to create the perfect shadow, was now a reality. The thermal performance of the deployed Sunshield has been nothing short of remarkable, exceeding even the optimistic predictions of its designers. It has successfully created 2 separate worlds on a single spacecraft, one hot and one unimaginably cold. The successful deployment did not just save a mission, it unlocked a new era in astronomy. The telescope is now consistently delivering images and data of a quality that have left scientists astounded. We are seeing the universe with new eyes, peering through cosmic dust clouds that were once opaque, and gazing back to when the first stars were lighting up the darkness. Perhaps most exciting is the study of exoplanets. Webb can analyze starlight filtering through planet atmospheres, searching for water, methane, and potential biosignatures. For cosmologists, Webb is a time machine, providing the first direct views of the very earliest galaxies, allowing them to test models of the Big Bang and cosmic evolution. The story of the Sunshield is more than just a tale of materials and mechanisms. It is a profound lesson in human ingenuity, perseverance, and collaboration. It brought together thousands of individuals from NASA, the European Space Agency, the Canadian Space Agency, and numerous industry partners across multiple countries for over 2 decades. The culture was one of learning from mistakes, meticulously investigating root causes, and implementing robust solutions. This resilience in the face of adversity is the hallmark of great engineering. As Webb continues to send back its stunning postcards from the dawn of time, we should remember the incredible human story of the shield that protects it, a story of dedication, collaboration, and the relentless pursuit of perfection that now allows us to see the universe as never before.